Alright, today we're going to talk about listing all possible outcomes for a game of chance. Now when you play a game of chance like the spinner games that we've played in previous lessons, there's always a possible outcome. Now you want to list all those possible outcomes to help you determine a game's theoretical probability. So to organize our list of all possible outcomes into a nice and neat organized list, we're going to list them in something that we call a counting tree. So we're going to think back to lesson 2 in that spinner game to demonstrate how to make a counting tree. So when you played that game in lesson 2, you used a spinner that had 2 colors on it. So you used a spinner something like this. Okay, and now for my spinner, I'm going to say that one side was red and one side is blue. Now the rules for this spinner game were you spin it twice, and if you land on red, you would call that a match. If you spun it and you landed, let's say, red first and blue second, that was a no match, and we call this a match, no match game. Now for this match, no match game, we're going to use something called counting trees to list all possible outcomes for that game. So to make a counting tree for this game, what we're first going to do is we're going to start at a starting point. So we're going to make that starting point on the board here. Now, our starting point when we're playing the no match game is just when the spinner's resting there. We haven't touched it, we haven't spun yet, okay? So, now when you played the no match game, the first thing you'd do is you would spin once. So, in my no match game, when you spin once, you have 2 options. You can either spin a red, or you can spin a blue. So this is the beginning of my counting tree. I started here, the beginning of my game, I haven't done anything yet. I spin once, I can roll either a red or I can roll a blue. Now you can see these 2 lines kind of represent the branches of a tree. That's why this is kind of called a counting tree. So after my first spin in the no match game, I can roll red or blue. So I'm going to label above these first spin. Now, when you played the match, no match game, you had to spin twice. So, after I spin the spinner once, I get red or blue, and then I would spin again to see if I got a match or a no match. So, after I start this game and I spin, let's say I spin a red, okay? Then I would spin again, and I can spin either a red again, or I could spin a blue. Okay, so if you're looking at this, you would start, beginning of your game, spin once, you could spin red. And then when you spin again, you could either spin red or you could spin blue. So here we have 2 more branches on our counting tree. Now, the last 2 branches on our counting tree are, say we started this game and we spun a blue, then we could spin either a blue again, or we could spin a red. So above all these options, these were my second spins. So above those, I'm going to write second spin. Now I've created a successful counting tree for all possible outcomes for the match, no match game. Okay, so now I can use this nice organized list to make a chronological list of all possible outcomes for the match, no match game. So using the counting tree, I'm going to make a list of all possible outcomes for the match, no match game. And I'm just going to list those right here. All right, so if I'm using my counting tree for my no match game, I started. Now let's say I go this way on the counting tree. So I start my game and I spin a red. Okay, that's my first spin. Then I spin again and I spin another red. So my first outcome is I can spin red, red. Now let's say I go again. I could spin a red first again this time, but my second spin, I could spin a blue. So my next possible outcome is red-blue. Now, let's say my first spin this time happened to be a blue. So I could I could spin first and get a blue. I could spin again and then get blue on my second spin. So I could get blue, blue as a possible outcome. All right, now let's say I start the match, no match game. I spin a blue, and then my second spin, I could spin a red. So I could spin blue, red as a possible outcome. So now looking back at our counting tree and our list of all possible outcomes, we can go back and we can make check marks on our counting tree to make sure that we've listed all our possible outcomes. So one way that we could spin is we could spin red, red. And if you go back here, you go red, red, okay? And then here, you could go red, blue. So you could spin red, and then you could spin blue. And then another possible outcome is first spin blue, second spin blue. And our last possible outcome is you could spin blue, and then you could spin red. So if you look back to your nice organized counting tree, you can see that we have checked off and we have listed every single possible outcome for the match, no match game. So all the possible outcomes for the no match game are red, 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 blue, 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 red. Now you can use this counting tree and the list of all possible outcomes for the no match game to determine the theoretical probability for spinning something in this game. So you can now look to your list of possible outcomes and you could say, what is the theoretical probability of spinning red, red? Well, you would look at your list of outcomes and see there are 4 possible outcomes for this game. So every theoretical probability for this game is going to be out of 4. Now, you want to know the theoretical probability for rolling, or spinning, I should say, red, red. Now, if you look to your list of possible outcomes in your counting tree, you can see that there's only one outcome that's red, red. So you would say your theoretical probability for spinning red, red is 1 out of 4, or 1/4. You have a 25% chance of spinning red, red. So this is how you make a counting tree to list all your possible outcomes. Using this counting tree will help you to list all possible outcomes and find theoretical probabilities for other games of chance